The next thing we'll be reviewing regarding radicals will be adding and subtracting radicals. Remember, to add and subtract radicals, you have to have like radicals. What do I mean by like radicals? Like radicals have to have the same root and the same radicand, meaning the same number under the square root. In the first example, if what's under the radical is the same, then we can add radicals like we add variables. We add the numbers out front and keep the radical. So in example number 10, 2 plus 5 is 7, and we keep the rad 3. In example number 11, what's under the radical is not the same. But if we look closely, we notice that each one of those radicals has perfect square factors. So we'll simplify first and then see if we have like radicals that then we can add or subtract. So the square root of 20 I can break down into rad 4 and rad 5. The square root of 45 I can break down into its factors of rad 9 and rad 5. The square root of 4 is 2, so I have 2 rad 5, and the square root of 9 is 3, so I have minus 3 rad 5. And now that the radicals are the same, I can subtract the numbers out front. So 2 minus 3 is negative 1, or simply just negative rad 5. The same is true in number 12. Right now, nothing under the radicals is the same, but there are perfect square factors in 175. So we'll factor that down to the square root of 25 times the square root of 7, keeping the square root of 7 and the square root of 5. The square root of 25 is 5, so I end up with 5 rad 7 plus rad 7 minus rad 5. I can continue to add or subtract whichever terms have the same radical. So I can add the first two terms, which is 5 rad 7 plus 1 rad 7, which gives me 6 rad 7, and simply subtract the rad 5 and leave it. Distributing radicals is a combination of multiplying and adding and subtracting. So we'll distribute and then see what we have left and see if we have any like terms that we can add or subtract. So in example number 13, if we distribute 3 rad 5 to rad 5, we'll get 3 rad 5 times rad 5, which is just 3 times 5. And when we distribute 3 rad 5 to negative 2, we'll get minus 6 rad 5. When we simplify, 3 times 5 is 15 minus 6 rad 5. And since there are no common radicals, that will be our final answer. In example number 14, we need to double distribute, or FOIL if you will, just like we did with variables. So we start with the first terms, so 2 rad 5 times 4 rad 5. Outside is 2 times 4, which is 8. Inside is rad 5 times rad 5, so just 5. The outer terms are 2 rad 5 times 1, so I get plus 2 rad 5. The inner terms are negative 3 times 4 rad 5, so negative 12 rad 5. And the last terms are negative 3 and positive 1. So when I multiply those, I get negative 3. We're looking to simplify and add or subtract like terms. So 8 times 5 is 40. I can combine the two like terms with the rad 5. So 2 rad 5 minus 12 rad 5 is negative 10 rad 5. And subtract 3. And again, combining like terms, I end up with 37 minus 10 rad 5. The final example of 5 plus 2 rad 3 squared, remember, means we're multiplying two of those together. So it's essentially saying 5 plus 2 rad 3 times 5 plus 2 rad 3. And again, we need to FOIL or double distribute. So 5 times 5 is 25, multiplying the first terms. Multiplying the outer terms, I have 5 times 2 rad 3, which gives me 10 rad 3. The inner terms of 2 rad 3 times 5 gives me another 10 rad 3. And the last terms of 2 rad 3 times 2 rad 3 gives me plus 4 times 3. Simplifying and adding like terms, I have 25. Adding the like terms in the middle, I have 20 rad 3. And multiplying at the end gives me plus 12. And simplifying one step further gives me 37 plus 20 rad 3.